Alright, so we're back to solving differential equations, but this time you're going to notice that the differential equation is not 100% in terms of x like we saw before. So here, notice we have a combination of x's and y. So we're looking to solve for y, and our differential equation is x squared y squared, and we're told a point on f of x, so we know that when x is 1, y is 1. So we are looking to solve. So we're going to use a technique called separation of variables. So what we are going to do is literally separate the variables. So here's how we do that. So we're going to take our original equation here and we're going to cross multiply. Okay, so step 1, so over here I'll just jot down the steps. Step 1 is to cross multiply. Okay, step 2 is going to be to separate the variables. That means we're going to want to get the y's on one side and the x's on the other. So when we cross multiply, we get 1 dy. Usually we put the y's in the left hand side of the equation because in the end our final answer is going to be y equals something. So we have 1 dy equals, and then we have x squared y squared dx. So I just did basic cross multiplication there. Okay. Well, notice how I have a dy on the left side, a dx on the right side. So we want to have all the y terms on the left side where the dy is, and all the x terms on the side where we see the dx. So notice how we have x squared times y squared. So to bring over this y squared, I would need to divide it. So I'm now left with 1 over y squared dy is equal to x squared dx. Now, the next step from there, once we have separated the variables, is to integrate each side. So that means we're going to draw in our integral. So it makes sense, right? What we do to one side, we must do to the other. So we're going to integrate each side. Well, let's do a little prep work first on the left-hand side here. So this 1 over y squared, this is the same as bringing up that y squared as y to the negative 2. Okay. And from there on the other side, I'm just going to copy this again. So now we're ready to integrate. So you're going to use your normal integration rules. Here it's just going to be the basic power rule, but sometimes you might have to do the if-diff technique, possibly use substitution. Alright, so we want to keep all of your rules in mind. Alright, so we're going to integrate each side. So this is going to give us y to the negative 1 when we add 1 to that power. And then we're going to be dividing by that negative 1, so we'll just put a negative in front. Alright, and then equals. Now we're not going to put a plus c on the y side, we're only going to do it on the x side. So we're going to add 1 and then divide by that 3 would really mean multiply by 1/3, and then we have our plus c. So at this point you are going to find c in your next step. You're going to find c by plugging in the initial condition. So let's jot that down by plugging in the condition. Okay, so this is where we're going to just stop and plug right in. So the x value is 1 and the y value is 1. So if we do that, we end up with, so we have negative 1 to the negative 1. So you're just plug it in whatever they give you. And then we're going to solve for c. Well, 1 to the negative 1 is the same as 1 over 1 to the positive 1, so that's just 1. Alright, and then it would be negated, so we would have negative 1 is equal to, and then over here you'd have 1/3 plus c. So that's going to give me c is equal to negative 4 over 3 when I subtract over 1/3. Okay, so that's my c value. So the next step is to then plug it back in, alright, and then solve for y. So I'm just going to go up here. Step 5 would be to solve for y. That's our final step. This is where we're going to get y alone. So let me go up here where I have a little bit of room. So this negative, let me just copy over what we have. So we have negative y to the negative 1 is equal to 1/3 x cubed, and we said that c value is negative 4 over 3. Okay. Well, let's get rid of this negative in front. Okay. And this y to the negative 1 is the same as 1 over y. It's really 1 over y to the positive 1, or just write it as 1 over y. And if I were to divide over that negative, I'd have a negative 1/3 x cubed and then a plus 4 over 3. Okay? And we could also, if we wanted to, since we have a common denominator, this is the same as negative x cubed plus 4 all over 3. My final answer here, I don't want 1 over y, I want just regular y. So my final answer here, if I want to get y alone, sure, you can cross multiply, or you could just flip each side, right? Just take the reciprocal of each side. So you would have 3 over, and instead of writing negative x squared plus 4, I could write 4 minus x cubed. Did I say x squared? X cubed I meant. So this is our final answer. Again, if it's multiple choice, you're likely to see it in this form. Okay, let's look at another example. Alright, it's not going to get much tougher than this example. If you can handle this, you can handle any of them. So we're told to solve, and remember what's implied by that is to find y equals for your final answer. So again, we see a combination of x's and y's, and by the way, this is kind of like implicit differentiation, where we needed another technique when we had a combination of x's and y's to find our derivative. So here, separation of variables is kind of like implicit differentiation, in that we just need another technique. So, like before, first step, put this over 1 and cross multiply. So we have 1 dy, or you can just write it as dy, equals y plus 3x plus 4, and then a dx. So that x plus 4 factor I want to keep there, because that's an x term. However, this y plus 3 I need to divide over. Okay? So we have 1 over y plus 3 dy is equal to x plus 4 dx. Now you can remove the parentheses if you want. When we go to integrate this, it doesn't matter. We're going to be integrating each part. Alright, so we need to just think about our integration rules. So this 1 over y plus 3. Well, with the last problem we had 1 over y squared. I was able to bring up y squared and write it as y to the negative 2. I was able to add 1 and just do my normal power rule. Well, 1 over y plus 3, if I were to bring up that entire quantity, it would be raised to the negative 1, and then adding 1 to that would give me 0, right? So that means that this is going to be the natural log, right? It's that special rule. So it's the natural log of technically the absolute value of y plus 3, okay? And remember too that there's a linear inner function here. Its derivative would be 1, so we don't have to worry about reversing our chain rule, okay, since it's just 1. On my other side here, when I integrate x plus 4, I'm going to get 1/2 x squared plus 4x plus c. Excuse me for a moment while I let my dog out. Okay, back for more fun. So again, we only need a plus c on the x side of things. As soon as you write that plus c, stop and then plug in the condition in the problem to figure out what c is. So we know that the y value is 1, so that's going to give me the natural log of 4 equals, and then over here we're going to plug in a 0 for x, and that's just going to give us c over there. So c is the natural log of 4. So let's now resubstitute. Let's go back to our equation. We have the natural log of y plus 3 is equal to 1/2 x squared plus 4x plus, and now we can replace c with the natural log of 4. So we've separated our variables, we have integrated, we have found our c, we've substituted in what c is, and now our last step is to solve for y. And you can see where y is, Okay, it's inside this natural log. So recall that if we are going to undo a natural log, we need to take e, we're going to raise up each side as the power of a base of e. Alright, so when we do that, when we drop an e underneath the entire left side and the entire right side, this will cancel out. And so now this is where it gets a little bit interesting. So I can now remove my absolute value symbol since the log is gone. So I have y plus 3 is equal to, I'm going to copy this over, e raised up to the 1/2 x squared plus 4x plus ln of 4. Okay. Sure, you could subtract over 3, and if you were to do that, let's copy this over one more time. Now that minus 3 is not part of your power. Okay. So if this is a non-multiple choice question, and it just said to solve, well, this is a solution. But odds are this is going to be multiple choice. And guess what? This will not be one of the answer choices. So how could you possibly simplify this? Well, this is stuff we talked about last year and actually the years before that. Remember that when you are multiplying and you have equal bases, you would add your powers. So, working backwards from that, what we can do is insert more e's into this by multiplying this, okay? Because remember, when you multiply and you have the same base, don't we add our powers? So I just put 3 e's into the problem. I've removed the plus signs that you see up above. Again, when you're multiplying and you have the same base, you could write this as the same base of e and then just add all of your powers. So here we're just working backwards, okay? So what that enables us to do is in this part right here, we could then have this 4 fall down, and we can write this as y equals 4. We'll put that as the leading coefficient. I'm going to then go back and write this as 1/2 x squared plus 4x, so we don't see more than one e in there, and then minus 3. So if this is multiple choice, I can almost guarantee you this is going to be what shows up. Okay, so it's not a calculus principle there, it's just an exponent rule. Alright, again, when you multiply and you have the same base, you add your powers, so we're just working backwards there. Alright. Okay, time to go help put the kids to bed. Bye-bye.